Today on the Workbench, we kick off our series on RF filters, including diplexers, triplexers, mobile duplexers, and base station duplexers. Stay tuned. Hi, this is George, KJ6VU from the Ham Radio Workbench podcast. Today we're going to talk about diplexers. Diplexers are a 3-port RF filter device that's used to split an antenna or radio amongst multiple bands. So you might, for example, have a single radio and need to go to 2 different antennas, perhaps an HF antenna and a VHF antenna. Or you might have multiple radios going to a single antenna. A diplexer is essentially a high-pass and low-pass filter in a single box. And they're very inexpensive, only about $65 to $90 typically. So today we're going to take a look at how these devices work on a Siglent spectrum analyzer. We have a model SVA1015X. This is a great spectrum analyzer, especially for hobbyists, because it's not that terribly expensive and provides a lot of functionality. This unit is good up to 1.5 gigahertz, which means that it's useful for all of the amateur bands, HF, VHF, and UHF up to 1.2 gigs. In addition to being a spectrum analyzer, it also has a built-in tracking generator. The tracking generator essentially is a signal generator that sweeps across the frequency spectrum and allows us to look at filters like low and high pass filters, as well as narrow filters like duplexers. So let's go ahead and take a look at a typical diplexer. Let's start out by describing exactly what a diplexer does. We'll use a frequency and signal strength chart here. So what we have in the y-axis is the amplitude of the signal. At the highest point here is where we have the highest signal level, and here at the low end of the chart is where we have the lowest signal. And typically these charts are graded in decibels. 0 dB, meaning that there's no attenuation of a signal, minus 20, minus 40, minus 60, minus 80 dB is a typical kind of range that you might see. And that's plotted against the frequency of operation. Here at the left side we'll have the lowest frequency, and here at the right side the highest frequency. So let's talk about what a diplexer is. A diplexer essentially is a high-pass filter and a low-pass filter in a single device. So what is that? Well, first of all, let's take a look at what a low-pass filter would look like. A typical low-pass filter would have a roll-off curve that looks something like this. What we see here is up at the high end, most of the signal is being passed from this frequency to about this frequency here. So this would be the band pass up to this point here. And as we go higher and higher in frequency, the signal is attenuated until it's almost entirely gone. So this is our low-pass side. A high-pass filter is the exact same idea, but you attenuate the low frequencies, and then there's an upward curve to the point where you're passing frequencies, and here now we see where the high-pass would be. So a low-pass filter and a high-pass filter in a single device. If you think about this from a schematic perspective, you could draw this kind of a filter very simply. Now inside these filters, they're typically LC circuits, so they're combinations of coils and capacitors. But essentially, you've got port number 1, which is your first radio, and port number 2, which is your second radio, radio 1, radio 2. These come into the diplexer, and then you have port number 3, which would be, let's say, your antenna port. So let's say the port 1 is your low-pass filter, and port number 2 is your high-pass filter. So a common kind of filter for this application is something like this Comet diplexer. And you can see here on this port, it says 1.3 to 30 megahertz, the HF band, and over here 49 to 470 megahertz, or the VHF-UHF band, and then this is the common port over here. So in this kind of a diplexer, this would be used, for example, to take a radio with a single coax connector that runs both HF and VHF into the diplexer, and then split to your HF antenna and your VHF-UHF antenna. So if we look at that in terms of this diagram, perhaps port 1, the low-pass filter would be for our HF radio. Port 2, our high-pass filter, is for our VHF radio, and they get combined together and go to the antenna. Simply, that's all a diplexer is. Now, diplexers are not only rated in terms of frequency response, but they're also rated for insertion loss and isolation. Insertion loss means that when I inject a signal into, let's say, the common port, how much attenuation should I expect before that signal comes out this port over here? And often the insertion loss for a device like this is on the order of a fraction of a dB, maybe 0.2, 0.3 dB. The other specification you'll see is isolation. And what that means is, what's the isolation between these two filters here? So if I have a signal that comes this way, that signal will also go this way, but it'll be greatly attenuated. So that's called the isolation. Isolation is typically 50 or 60 dB, so it's pretty substantial. It's enough to keep a transmitted signal from blowing up a receiver. So let's say, for example, we have a common antenna and we have a HF radio and a VHF radio. If I'm transmitting in with the VHF radio going out to the antenna, I will ultimately have a little bit of energy coming back over to the HF side, but it's going to be so attenuated that it won't do any damage to the radio. That's really how these things are built. Now let's go ahead and take a look at what the frequency response curve for something like this looks like on the spectrum analyzer. So here you see a screen snapshot of the Siglent SVA1015X. One of the features of the Siglent that I really like is a built-in web server. So I don't even have to put the camera on the screen of the device. I could just look at the web page that's being served up by the instrument. So what you see here is that we have our spectrum analyzer hooked up to the common port and also to the HF port. And as you can see on the screen, we're looking at a frequency range from 0 to about 470 megahertz. And if you look at the far left-hand side, here you can see that the low pass is working great over here. So from about almost, let's say, 1 megahertz up to this point here, which is about 30 megahertz, it's pretty flat. And then you get some pretty steep attenuation, a little bit of a bump, and then you're down in the noise. Now, the signal that's coming out of the spectrum analyzer is already attenuated by 20 dB. So it's 20 dB, minus 20 dBm coming out of the spectrum analyzer. So essentially we're getting almost zero loss here. The difference between our pass frequencies and our blocked frequencies is the difference between about 60 dB and 20 dB. So we're getting 40 dB of attenuation on this one side. If we are going to disconnect from this HF port and move the connection over, as you can see now we're not connected, so there's no signal at all. And now I screw this into the other side, into our VHF UHF port, you can see the frequency response curve is now completely different, where the HF spectrum is attenuated by that 40 dB plus, and all of the frequencies that are passing are all well above 30 megahertz. So here you can see the high pass filter side of the diplexer. Simply, that's what a diplexer does. Well, I hope you found this video useful as a brief introduction to a diplexer. We talked about diplexers and other RF filters in great detail on our episode 157, RF filters. We talked about not only diplexers, triplexers, quadplexers, and pentaplexers used for most stations. We also talked about duplexers and isolators and circulators, the kind of devices that are typically found in repeater systems. So give a listen to episode 157, and we hope you enjoy it. Thanks a lot for being a listener to the podcast, and thanks for checking out the video. 73,